this is a continuation of our computation for the domain of f of g, which we're going to get algebraically, and we're going to show that it agrees with our graph in part A, which is, again, the encircled one in here. So going back, as I have told you, we have a newfound domain, which is here. I'm going to highlight it. It's this one. Now this newfound domain is it's not yet the official domain of our f of g of x, because it has to undergo, certain manipulations. Now this newfound domain that you see, this newfound domain has to be crossed with our domain for our g of x, because remember, this domain of g of x should also be taken into consideration. So our first step here is this one, and then we found the domain for our f of g of x. Now we're going to get the intersection of our domains for g of x, and we're going to intersect it with our domain for f of g, because the domain restriction for g of x is very much also a necessity in solving the domain restriction, the official domain restriction for our f of g of x. So we have our domain restriction for the g of x is from 0. So our domain for g is from 0 to 7. And our domain restriction for our f of g of x, which we found by computing graphically, is equal to x, which is from -1 to 4. Okay, we make a number line here. Okay, we have to make use of vertical line. The horizontal line. Okay, so let's add this. Okay. And we're going to define the domain restrictions. So 1, let's make it here. Anyway, it's from 0. Okay. 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 5, 6, 7. Okay. This is for our d of g, the domain of g, and this is for our d of f of g. Okay. So 0, 1, 2, 3, 4, 5, 6. In this case, we have to add another 1. This is supposed to be 7. This is 7. And this one, we have 0, 1, 2, 3, 4, 5, 6. We have to add another 1 for the -1. So this is -1, -1. Okay. Now let's do the crossing over. What is the domain for g? We have from 0 to 7. So we have here. It's from here. It's from here, okay, to 7, which is here. Okay, what is our domain restriction for f of g? -1 to 4. So let's make this this color, this one, and this one. Okay. So DOG is 0 to 7, this 1 to 7, so this to this, and for our FOG, it's from -1 to 4. So what do you notice here? Our domain restriction is now in between. Okay, we have to get the value which is common for both the domains. So in that case, our domain would then be, okay, from this value, right? This is where they are common, so that's the intersection. So therefore, our domain, the newfound domain, which is the official domain, would then be from X, which is in between 0 to 4. This is our domain. Now let's check if that domain corresponds with our graph in part A. Our domain, remember, our domain for FOG is from 0 to 4. Let's take a look. Our domain for FOG would then be here. If you take a note here, I'm going to write down or show you the domain. So from here up to here. So it's from 0 to 4, which corresponds to our graph for this particular domain from 0 to 4. Find an equation for FOG of X explicitly in terms of X. Simplify as much as possible. Plot the graph of this equation on the same screen as your graph in part A, observing the domain in part C. Does the graph coincide with the one you plotted in part A? Let's take a look. This is our G of X. And this is our F of X. Okay, we're going to solve them explicitly, meaning it should be expressed in one variable only. In this case, explicitly means to be expressed in a certain variable. In this case, it's X. Okay, so we have G of X is equal to 5 minus X. And our F of X is equal to negative, or F of X, let's make it F of G of X now. F of G of X will be equal to negative of 5 minus X square plus 8X, so 8 times 5 minus X minus 4. So let's compute, simplifying the one in the parentheses for the quadratic for this part, okay? The one with the second exponent. Okay, we will have 25 minus 10x plus x squared plus 40 minus 8x minus 4. And that will give us negative 25 plus distributing our negative here to all parts of the expression plus 10x minus x squared plus 40 minus 8x minus 4. And now we have to combine all of the common terms here. We have 8x and 10x. And we have these three terms, the numerical coefficients, the number, the constants, okay? So proceeding, we will have negative x squared plus 2x. And that's plus 11. So that's what we got. And now we have a domain restriction of 0 to 4. So this is what we got for our f of g of x. And this is our new equation, new function, f of g of x. So if you want to graph that, we have a lot of ways to graph it. If you want to graph it manually, you can use either tabulation, creating a table. You can also use the vertex plotting, wherein you have to solve for the complete square. Okay? And let's try to do that in this case. To graph it manually. Well, you also have your grapher if you don't like to use this method. Now this is like an extra. Okay? So our f of g of x is equal to negative x squared. So we want to complete this square, so negative x squared plus 2x should be grouped plus 11. And we're going to complete the square for this part. So negative x, negative, we put the negative outside. That means that we also have to make this negative. So this one becomes negative. So we have negative here. And to complete this square, we have to divide this by the middle term, divide the middle term by 2. So 2 divided by 2 and then square it. That will become 1 squared. So that's equal to 1. Okay, so our completed square then will become, this will become 1 and plus 11. And notice this is negative, so if you multiply this here, it will become negative, so we have to add 1 here. Therefore, we will have negative of this, just a complete square, okay, x minus 1 square plus 12. Now we have a vertex occurring at 1 and 12. And this is negative, so if that's negative, if that is negative, then we assume that it opens downwards with a vertex occurring at this point, 112. Now let's see. Since our restricted domain is only from 0 to 4, now let's see our graph in part A. We have from 0 to 4, from 0 to 4, and our vertex is occurring at 112. So this case, from here, okay, that's 112, okay? So this is our vertex. And it opens downwards. And we have a restricted domain from 0 to 4. So our graph coincides with the one plotted in part A. And that ends this problem set number 4, quadratic and linear function. Given our f of x equal to negative x squared plus 8x minus 4, restricted domain from 1 to 6, and g of x 5 minus x, with restricted domain from 0 to 7. And we get the 3 graphs here. And our f of g of x, of course, we get a restricted domain from 0 to 4, and that ends this explanation. Thank you for watching.